Right, shall we get started? It's 10:02, so I think it's time. So hello everyone, and thank you for joining us this morning. I'm Kontsevoy, CEO of Gravitational, and today we are going to be talking about Kubernetes security. All right, security is a big topic, and to be more specific, and also to make this time count, to make it more efficient, we're going to zoom in just one aspect of Kubernetes security, and that is the best practices for auditing it. As we go, please feel free to ask questions. Notice there is a little Q&A button on Zoom. You can click on it anytime and type in your question, and as we go, we'll be collecting questions and then we'll be answering them at the end. Also, before we jump into juicy details and demo, I want to introduce you to Andrew Lytvynov, a senior security engineer here at Gravitational. Hey, Andrew, you have to unmute. So what makes you a good expert to talk about Kubernetes security features?
Hey, everyone. Yeah, I know a little bit about Kubernetes security. I worked for about 2 years on the Google Kubernetes team, on the security team specifically, and was pretty heavily involved with SIGAuth, contributing various security features and fixes to Kubernetes itself. And right now I'm also working on Teleport, which, among many other things, does security access control for Kubernetes and also audit logging for it.
Yeah, so in case the audience doesn't know, Teleport is an open source project that Gravitational is working on that allows you to control access to all of your servers, to your Kubernetes clusters, and everything else. So, also, let me introduce myself real quick. So why am I here? Why am I qualified to be on this panel? Well, that's because, again, I co-founded Gravitational several years ago, engineer by training. And prior to starting this project, we were all basically working on cloud infrastructure at Rackspace, which is, back in the day, was one of the leading cloud providers. 7 data centers, regions all over the world, many different infrastructure form factors, and all of our customers were constantly basically asking us for advice. How do I make my environment secure? How do I unify my security practices across cloud, on-prem, VMware, OpenStack, AWS, Rackspace, Azure? And that's really why Gravitational got started, and that's why we started working on this project. So with introductions out of the way, let's dive into the main topic. Okay, Kubernetes. As organizations adopt Kubernetes as a primary method of getting their applications deployed, they have to remember that it's just yet another platform that they're running on. And it's not really replacing anything else. It's running on top. It's just yet another layer of their technology stack. So it only adds to the surface area of a possible attack. Let's just remember that. And also let's go over like what are the other basic layers that exist. So if you're building on top of Linux, which is obvious in this case, so that's one layer that you have to protect and you have to take care of. So the operating system layer of your stack. Then if you're running on a cloud platform like AWS or Azure, so remember that's another surface area, right? Because someone can gain access to your like AWS environment, and then operating system security kind of doesn't matter at that point. So Kubernetes is one of those things. So Kubernetes lands on top of those two. And again, that's just another door that someone can access. And that's another way how your production environment can be compromised. Like I don't have to hack into AWS account. I don't have to hack into Linux servers if I can hack into Kubernetes API. So Andrew, from a security and audit perspective, and keeping what I just said in mind, what are the changes that you think engineering teams need to consider when adopting Kubernetes?
So when you adopt Kubernetes, odds are that you will end up with multiple clusters. You'll have your development, staging, production, whatever, or you can have clusters per region, for example. But in order to deal with all of those, you really want to centralize the access. So you want to pipe all of your developer access to your clusters through a single choke point such that you can enforce your policies there.
Like a gateway.
Like a gateway, right.
Mm-hmm.
And while you have that in place, it's a really nice place to attach your SSO identities to any requests and any modifications. That way you get accountability from everyone in your organization, but who does what to your production or staging environments. So you really want to make sure that the gateway only allows SSO users through and records that, that identity with the request. The other thing is, even though you're using Kubernetes, it hides a lot of the ugliness of the underlying hardware and infrastructure, it still is all there. Like the servers are still there, they're still operating systems, and most likely you still manage everything under Kubernetes via SSH or something similar. So you don't want to forget about those aspects. And if you are not relying on SSH, you can just disable it entirely. If you are relying on it, a good practice is to synchronize access. So try to use the same gateway that you use for Kubernetes to go with SSH. And then also obviously do all of the same enforcement that you do for Kubernetes. So attach SSO identities, do access control, all of that. So don't forget about SSH. And then the other thing that all of this extra complexity, all of this extra code on top will generate, like, cause more changes and generate more audit logs. So you have to think about collecting some new types of audit log data.
So you mentioned multiple types of audit data. So that might be like a question-raising statement, because as most Kubernetes users are aware, well, Kubernetes has just a single audit log. So what do you mean by multiple types of audit data?
Yeah, so as I mentioned already, like all the underlying infrastructure is still there. So you still have all of your existing audit logs from SSH, from your operating system, package updates, what have you. But Kubernetes also has nice abstractions on top that also generate their own logs. So one example is network logging. If you use something like Calico or any other networking plugin, they usually are able to generate network logs. So you can record what services talk to each other and who's talking to your services externally. Another thing you want to look at is runtime logs. So basically that's execution logs. What binaries are your pods executing and what changes are they making to the file system? And things like Falco can give you that pretty easily. And like the most impactful thing, if you just want to do one and you don't want to deal with all this third-party software, you want to enable the Kubernetes native audit log. And this basically logging all of the access to the Kubernetes API. So any changes to your cluster resources. And this logging is controlled by the native Kubernetes audit policy.
Audit policy. So we should dive into that. But I just wanted to make an interesting observation. As you were describing like all these additional things that run inside or alongside Kubernetes, and all of those things generate their own audit information, that actually reminds me of this analogy. You know, it's how people say that data center is now a computer, and Kubernetes is an operating system for that computer. So if you're going to draw the analogy between a single server and Linux, and how Linux has var logs, and Linux itself, for example, like when the kernel is booting, it's placing its own kind of logs in there. But then most applications, if they're well designed, that run on Linux, they're supposed to put their logs in there. So that was kind of historically how we've been doing logging on Linux. And now with Kubernetes, basically the same thing. We have Kubernetes itself producing logs, and we have all these other things inside of Kubernetes doing it. And I guess our view is that you should centralize and audit all of these things in one place. So going back to Kubernetes audit policy that you mentioned. So what is it for those of in the audience who don't know? Like, what is it? How do you use it? What are the best practices for tuning it?
Yeah, so audit policy is this native Kubernetes configuration object that you provide to your API server. And basically it dictates what kind of requests you log and how much information you log about them. So in terms of what requests, you can say only log anything that's done to pods or anything that's done to secrets, or everything that's done to any of the core APIs, but none of the extensions or custom resource definitions. And then how much log, you get the choice of logging at the start of the request, at the end of the request. You get to choose whether logging, whether you want to log the entire request and response body or just the metadata. So what's the URL, what's the resource name, who did the request, and so on. You might be wondering, why don't you just like log everything, all requests, responses, just everything that it provides? And the reason is that Kubernetes API and control plane tend to be very spammy. And if you logged everything, you would just get like an avalanche of logs that are mostly just noise, and it would eat up your storage bills, and you would not be able to find anything useful in between there. So you want to tune for only things that you actually might care about. It's kind of intimidating to figure out what you might like care about in the future. And for example, Gkey has a policy that's publicly available if you search on Google. And it's a good starting point, that it has like a good balance between comprehensive log and reducing the amount of that log. Another kind of high level thing to understand about audit policy is that it really only defines what you log. It doesn't define where you log it. And so for that, your logs, after you've configured the policy, they end up in like a configurable audit sync.
Thank you. So that brings me to another point that I think we want to make in this webinar, is that auditing is only useful if you actually have a good plan in place how to use that information. In other words, the audit logs, they must be used effectively. Simply dumping them into one dark place is just not helpful. So consider using log aggregation and analysis tools. For example, we'll be doing the webinar later with the CEO of a company called Panther. So they have an open source tool that actually allows you to look into these things in real time and define certain rules. So think about using security logging and auditing almost like an offensive weapon to prevent problems from occurring or detecting them early, as opposed to being just like a retroactive forensic tool that you just consult when you're crafting your postmortems of successful attacks on your infrastructure. So, as a basic step, just consider consolidating all of your audit logging into a single system. Just like basic step, just have it all in one place, because this allows you to do all these advanced things in the future. And speaking of consolidation, Andrew, what have you seen in the wild? Because you've been helping Teleport users for a while now.
Yeah, so out there's really a ton of options. You have a lot of pretty mature SaaS providers. So that's Splunk or Sumo Logic, Graylog, others. And basically it's like, SaaS, it's a third-party service that does all of the log aggregation storage for you. You ship off the logs to them. Usually we are like a webhook or something similar. And they do all the processing. You like use their web UIs to deal with it, search it. Then usually most cloud providers will have some sort of an offering in their platform built in, which it's called, I think, Stackdriver on Google and centralized logging on AWS. But the idea is that really those integrate pretty well with that specific cloud provider, but they're not that great when you want to ingest logs from anywhere else. So if you run on multiple clouds, probably not the best option, but it's still there. You can also go for self-hosted if you have the the know-how in-house to run this type of software. One of the most popular things here is the ELK stack, which stands for Elasticsearch, Logstash, and Kibana. Those are three separate services that complement each other. They're all built by Elastic. And they really are meant to be like a comprehensive solution for logging and monitoring and visualization of all this stuff. And there's other sort of self-hosted log aggregation tools out if you search. But I guess the biggest problem here is that you end up with a paradox of choice. there's just so many good options that are all pretty mature that you're just stuck evaluating when you need to pick one.
So let's just say I'm using Splunk. It's a not unreasonable choice, and it's fairly popular and well. So then what? Like, what do I get if I use Splunk and I want to collect Kubernetes audit?
So after you set up log ingestion into Splunk from Kubernetes, you get, it's one of the more mature offerings, and it has a really powerful search. So you can search through all of your logs that you have ingested from anywhere, Kubernetes, all of your clusters, anything else, SSH, within seconds. And it's really flexible. It's not just like a regex. You can extract fields from there and so on. So that's really good for forensics. So after something happened, either a security incident or just a bug in production, you can use that to figure out what went wrong and like what the sequence of actions was. But another thing that Splunk and others offer that's way more powerful than just searching is treating logs as if they're monitoring. So you can create these saved searches that will extract some data from logs, some fields, or just count the logs matching a certain search query and present them to you as a metric. And that's really powerful because you can build sort of dashboards that give you a much better idea of what's happening than just scanning through like thousands and thousands of text lines. But also you can start creating alerts from that, which, for example, you can say, oh, if something is starting to read my Kubernetes secrets 100 times per second, alert me, like something's wrong. And alerts are, again, pretty flexible. They can go to a bunch of different destinations. So it can be Slack or email, or they can even page your on-call engineer if it's something really scary.
Yeah. So, and I'm assuming that it's not just Splunk. So similar solutions offer similar capabilities. And
yep.
Let's spice it up. So let's say let's do a quick demo. For example, something that a reasonably competent engineer can set up in less than a day, very simple environment, using mostly open source tools and whatever they have already. So Andrew, gonna pass it back to you. Let's show a demo of how this might all look like.
Yep, let me just grab my screen. Okay, hopefully you can see that. So yep. Let's imagine a scenario where I am an attacker and I have compromised a laptop of one of your engineers. So I have a shell open remotely into that engineer's machine. They don't know about it, no one knows about it. And essentially I have access to anything that that person has. And this engineer happens to be your like lead DevOps person who has admin access to all the clusters.
Yeah, the worst possible scenario, yeah.
Yeah, worst possible sort of insider risk scenario you can imagine. So as an attacker, my first reaction, assuming like I sort of did some reconnaissance, I know that this company is running Kubernetes and relying on it a lot. My first thing that I will try to do is just dump all of the secrets on all the namespaces in whatever cluster that this engineer was working with. So basically, this gives me a bunch of these tokens that a lot of them will be tokens for Kubernetes service accounts. So you can impersonate any service account that this cluster has. Some of them will be some other secrets, some like maybe your database credentials and so on. That's pretty bad. Another thing I might want to try as an attacker is run some malware, install some malware or ransomware or anything else on a inside of the cluster itself. So in this case, I was trying to log into the Kube API server and run this command. So just pull a script that I wrote and put on my website and pipe it into Bash, right? In this case, it didn't work, but whatever. And if I'm like a careful attacker and I'm trying to be really sneaky about what I'm doing, I don't. So I can just start a shell inside of that pod instead of passing the command and command line such that no one really knows what I'm doing. So from like the outside perspective, it looks like I'm just logging into a pod in my cluster and doing some maintenance work or whatever. But here I can do whatever I want, and it's all kind of obscure and hidden. So this is kind of what an attacker might try in this really bad scenario. But now let's sort of switch our imaginary location, and I'm the security engineer on the team right now. And the way I have set up our infrastructure is, first of all, I have this audit policy defined for the Kubernetes cluster. And this basically just says, like, whenever any response is finished to the Kubernetes API, log the metadata of it, like log which request, which URL was hit, log the username, and so on. And this is like, it's very minimalistic, very basic. It's not really what you should be doing, but it's just, it was very easy to set up and gives you a good enough amount of information. And from an architectural point of view, so here's what this little like demo infrastructure setup looks like. You have your user making requests to Teleport, and Teleport just works as a gateway in this scenario. The reason is if I had multiple Kubernetes servers behind it, Kubernetes clusters behind it, I could use just the same gateway for all of that. And also if I wanted to SSH into some nodes, I can do that through Teleport as well. So it's kind of a central gateway for everything. Then when a request makes it to the Kube API server, the audit policy kicks in. It says, hey, log this metadata about this request. And I've configured it to write to FluentD as a webhook. I'll explain what FluentD is in a second. And it's basically just pipes the same audit log over to Sumo Logic, which is the log aggregation platform that we're using in this case. It's similar to Splunk in a lot of ways. It's just something I could set up pretty quickly. And also at the same time as the API server is logging its own audit log, Teleport is also logging its own view of what happened into the same log aggregation platform. So everything is collected over here. So just to mention, FluentD is this great plumbing tool for logging. It's basically this intermediate service that sits in between your log sources and your log sinks or destinations and abstracts them away. So you can have multiple log inputs. So it can be collecting files. It can be collecting Kubernetes API logs, accept anything from a webhook, and then do some internal parsing, and then output that into any number of output sources. In this case, it's just Sumo Logic, but it could be sending them to some like archival storage in S3, and also to Sumo Logic, and also to somewhere else. So this is like very flexible tool that lets you insulate yourself from what your log aggregation provider is and what your sources are. Another slightly more detailed diagram is what happens when I do exec specifically. So Teleport will treat exec specially relative to other commands. And in addition to doing all of the logging as you usually have into Sumo Logic, we also record the entire session. So everything that happened, if it was a shell, everything that happened in a shell, all the commands that were executed, and so on. And it gives you a much more complete view of what happened than just the log of the request. So let me switch over here. So here I have my Sumo Logic page. So again, I'm a security engineer who's investigating what the hell is happening with our infrastructure. Why is there a bunch of malware getting installed? And it's taking a while to load. Okay. So I have the logging usually takes a few minutes to propagate. There are good reasons for that. Most of the intermediate steps will try to batch logs to kind of handle a large volume. So here we're looking at my previous attempts. I was just doing exactly the same request before. So this page will show us the, we're looking at pods. So this is just a Kubernetes API log, right? So here is an example of when I did kubectl get secrets in all namespaces. So you can see like that I'm getting secrets, unlimited namespaces. You can see who did it. So this is my username. That's my SSO username attached to the request. also what groups I was using, source IPs, and so on. So a lot of useful information, and you can sort of build alerts on top of this. When I did kubectl exec, it shows up as a pods create request because of how the API works, but basically it's this exec sub-resource on the pods that you create. And you can kind of just see the command in here. It's kind of obscured and URL encoded, but it's there. And again, all the same information. You can see who did this, when, what their user agent was, a bunch of stuff. But then when I was using, when I was just creating a shell directly instead of passing a script into kubectl exec, you can see that I started a shell, but you don't really know what I did there. So you know that it was an interactive shell that someone that Ali opened, but that's about all you know. So to complement that, let me show you the teleport logs. This is the stuff that teleporters collected while all of this was happening. So for the first command I executed, it shows us that there was an exec event. It shows us the exact command I passed in much more clearly than Kubernetes log does. It shows the exit code. Yeah.
Mm-hmm. It's like teleport shows what is inside of that session. Like Kubernetes tells you that an interactive session took place, but then in teleport you could see more.
Yes. And then also if you do like a fully interactive session and type in a bunch of stuff, you see it happening in teleport, and you see a bunch of the same information and who was involved, right? Who did this? But also if you use the session ID, you can actually replay everything that person did in that session. So in this case, I'm on my security engineer machine, and if I run this command, I'm not doing anything right now. This is teleport showing me what the person in that session typed, right? So this is like really powerful. You sort of peek through the attempt of this attacker to obscure their actions, and you can see exactly what they did thanks to teleport being in the way and intercepting all of this.
Yeah, people often ask, like, is this a video?
No, this is, so the way teleport stores this is actually raw bytes that were sent over the socket as the person was typing stuff. So this is like actual keystrokes, and then we sort of replay them against your local terminal. So it looks kind of like a video, and you can sort of look at it and view it as a video on the web UI, but really it's just the raw bytes of everything that was happening. Another thing, so I didn't set this up for the lack of time, but you can set up metrics based on logs in Sumo Logic and the other providers. It's kind of like a fancy language you have to figure out, but after you do, you can convert all of these logs that I was showing you before into metrics, and then you can write alerts on them. So alerts, for example, anyone on call whenever any user logs into a kube system pod. So no one should ever really log into kube system. That should be the control plane that's left alone. But if someone does, this is really suspicious, and you should kind of alert on that. But that is the end of the demo. Let me stop sharing.
Thank you, Andrew. So let's get our so what are the key takeaways that we tried to introduce in this limited time we had? So let's go over them. So just remembering that Kubernetes expands the attack surface of your environment. So, and to address that, the second point we we're trying to make is that if you introduce in one layer, like you have to make some other layer less relevant. Like turn SSH off for majority of your engineering team. They shouldn't need it anymore because you're using Kubernetes. Having both present and having both not synchronized just increases probability of you getting compromised. So that brings me to the third point here that we want to make is that if you do have SSH access enabled, if you have Kubernetes, apply role-based access control, synchronize the two, have exact same certificate authority, exact same authentication gateway and access gateway, letting access to engineers to both of these resources, Kubernetes and SSH. And also, which is point number 4, you should have, if you can, like a single gateway that is used for all of your infrastructure footprint. We see all the time when companies basically have these islands where they say, oh, it's a staging environment. It doesn't really matter. Or that's our research lab. They have their own auth. Look, it's not even like a matter of convenience. You could actually have groups and roles. Like role-based access control was invented specifically to partition your infrastructure into these environments. So do not create separate authentication and access endpoints, because things happen all the time. Valuable data might end up in staging by accident. Like a same machine could be transferred without re-provisioning from staging to production environment, and or vice versa, and it might have data on it. Just treat everything you have as one giant secure thing. Like these tools that we're talking about here, Teleport, Kubernetes, Alert Logic, they make it easy. So I would even argue that it's easier to treat everything all at once versus setting up multiple authentication endpoints. Also on consolidation, I want to mention something else that we haven't really covered, is that we see a lot of organizations use very separate kind of access paths for engineers and for everybody else. My guess is that it's historical. So for example, if they purchased some like application access product from a company and that was sold to protect like certain part of your workforce, so they go and roll it out for the rest of the company. But engineers usually say like, oh, we're fine, we have our own thing, we secure, we are engineers after all, we're the experts. Yeah, don't do that. Again, in 2020, there's like no reason for everybody at the company to be using exact same SSO. And it doesn't matter if they're themselves security engineer or they're working in marketing. Finally, well, not finally, the next thing we talked about is aggregate all types of in-audit information across all clusters in one place. Don't audit Kubernetes in isolation. Again, Kubernetes, think of it of an operating system. Sure, it has its own logs, but then you have SSH, then you have applications, and you have additional middleware. The best practice is to synchronize them all, because again, you don't really know what a portion of your stack might be under attack, and you probably want to enforce the same rules, and you want to have single dashboard or set of dashboards showing you what's going on. Which brings me to, there was actually a question that we'll probably get to. So export audit logs into specialized platforms that allow you to do all kinds of fancy things. This is not something that Gravitational does. That's a separate market. Again, we showed you Alert Logic. You could do a lot of interesting things with Elk stack. We could do Splunk, and there are a lot of specialized tools. And finally, treat the audit information. Basically, security monitoring is regular monitoring. Make effective use of this data. Don't just dump it into one giant black bag, hoping it will be useful one day. So that's, I think, the key points we wanted to convey. Now let's take a look at your questions. First, I want to go over questions that have been answered as Andrew was doing the demo. So the first one was, why didn't the first attack work? Well, that's because evil.com that Andrew was showing to download an evil script obviously was not a real domain with a real script. So the second question was, so does Teleport work like a bastion, or it only handles authentication? And the answer to that, it's both actually. Teleport, if you go to like gravitational.com/teleport, then click on how it works, it shows that Teleport consists of 3 small services. So one of them is a bastion-like proxy. We call it proxy because we believe it's technically a better term. And then there is also certificate authority, the auth server. So it handles both. And from a user experience perspective, what it does, it forces all users to go through exact same SSO process, both for Kubernetes and for SSH access. Now let's go to questions that we haven't had a chance to answer yet. So I'm gonna click here. So how does Teleport compare to other proprietary solutions, non-open source? Andrew, do you want to answer this? You want me to take a stab, or shall we? Like, I don't like to talk bad about competing solutions. Look, the obvious answer, they are proprietary and closed source. We, like the founding team of Gravitational, we believe that security cannot be closed source, because you get best security when the whole world, the security researchers and security engineers from companies like Google, that's how Andrew actually found Gravitational, because he discovered Teleport source code. That's how you can really say we are secure, because the whole world is your auditor. Andrew, if you want to add anything to that.
Yeah, I mean, that's it's a very major point in that you have, you can audit exactly what Teleport does. You can understand, we have a lot of documentation about the internal architecture details. You can understand what's happening under the hood. You don't just have to put a bunch of trust into a brand or vendor, right? The other thing is that Kubernetes Teleport gives you this sort of universal overarching solution that integrates very well. So it was originally built for SSH, integrates like really well with that, but then also Kubernetes. And the design of it, the architecture is such that it's extendable to work with any other protocols or any other remote access. There are some things we have in the works for non-Kubernetes, non-SSH stuff, but you know, it's too early to make promises. But the idea is that Teleporter is really good at handling authentication and authorization, and then where you pipe your data to and from is kind of a pluggable thing. Yeah.
Okay, so we're getting more questions. So let me go bottom up, because I hope I pronounced your name properly. Hazik Ruslan was asking if Teleport can be used to access internal web applications rather than SSH. The answer is soon. It's one of the most common requests we're getting. Like examples include internal wikis and Jenkins. So that is something we're working on, and it will be announced hopefully. Again, I'm not going to give you a deadline, but it's coming. It's coming. We're very excited about it. So then, does Teleport support log forwarding to SIM tools? Andrew?
So Teleport by default writes logs to like a local file, but you can configure it to write to a couple other destinations. So I believe we support S3, we support Google Cloud Storage, maybe one or two others that I forget, but the way you would set it up with the SCM in practice is by using something like FluentD. So that's exactly the reason why FluentD exists, is to do all of this plumbing. So you don't have to teach every tool that can emit audit logs to know about every like destination, every SCM that could accept audit logs. So FluentD is the solution there.
Okay, moving up. So can Teleport be used as a VPN solution other than for SSH access? The answer is no. It's not like VPNs are not, like Teleport was built, it's an opinionated system. And we probably all heard this kind of term zero trust, which a lot of engineers just dismiss as marketing speak. But Teleport is designed with this view that all of your important things that you're accessing, they should have public endpoint. That public endpoint should be encrypted, protected by identity and audit. So that kind of removes the need for VPN in this world. And it also kind of goes back to this earlier question, how is Teleport different from legacy and proprietary solutions? We believe, because Teleport is built with this cloud native view, and also we also believe that you are using multiple clouds at the same time. And we don't believe that location or the network affinity of a resource should even matter. Like Teleport gives you access to Kubernetes clusters that could be on any cloud without any VPNs. It could be inside of a self-driving vehicle. Teleport supports that. That's why it's called Teleport, is that it creates this illusion that all of your company compute is in the same room with you. That's really how it's different from a lot of other tools that are built with this. Like there's like IP address all the time. VPNs have to stitch things together. With Teleport, these things don't matter. So another question is, how can Teleport use or integrate with another certificate authority like Vault? instead of being its own. So I will offer like part of the answer. Like Andrew can probably add to it. What we've observed is that Teleport and Vault, they usually belong to different parts of an organization, where Vault is something applications use to store secrets. That's how most frequently it is being used. So Vault then becomes part of your application stack. It's something that maybe you are deploying actually alongside with your code or redeploying. Whereas Teleport is protector of your infrastructure. And oftentimes it helps to have these two concerns being separated. In other words, if you lose one, you still have the other. So linking them together, where your application domain and your infrastructure domain share the same source of like the same authority, might not be a best idea. Andrew, do you have anything to add here?
Yeah, one, and I don't know about Vault specifically, but one thing to know is that there's different kinds of CAs. So in most of the time when people talk about CAs, they talk about X509, so TLS type CAs, right? But that's not the universal kind. So when you use SSH, you use an SSH CA, and it's using different formats, slightly different. Like basically, you can just take a TLS CA and plug it into SSH. So that's one thing that a lot of secret stores might not handle out of the box well. And the other thing is kind of
so
similar.
Vault doesn't. Let's just be specific. Like Vault.
I don't know about Vault. I don't know if they do, but I would assume that most like less mature ones would not handle SSH CAs. The other thing, kind of similar to what I was saying, is that if Vault is running on a server somewhere, which is most likely the case, it's not running locally, and you use Teleport to access your servers, if Vault goes down, you can't access your servers, but you can also not access Vault to fix it, right? So it's kind of a chicken and egg problem, and it would be very scary to gate access to Vault itself with Teleport. So it's not a dependency you really want to introduce necessarily. It's better to split those concerns.
All right, so the next question is, if a user is running as AWS SSO user, AWS shows user who is performing operations in CloudTrail. Can we get user attribution in this case within Kubernetes, EKS specifically, as well as using GT? Like what is GT in this case?
I think it's CT CloudTrail.
Okay, CloudTrail, yeah. Basically, we need to know the AWS SSO user, not the mapped Kubernetes user, because that is based on a role. Andrew, that goes to you. That's awfully specific for me.
I'm not too familiar what protocol AWS SSO uses under the hood. So if it is something like OEDC or YAML, it can natively integrate with Teleport, in which case you can pipe all that stuff, and the Teleport audit log will tell you the SSO identity on the Teleport audit log side, but the Kubernetes audit log will not see it naturally. You could define a Teleport role such that it stores or it directly plumbs the SSO username over to a Kubernetes username. And it's like, it kind of makes sense. You would write your RBAC policies on Kubernetes to map against the SSO users you have. But if AWS is using some sort of proprietary SSO protocol, it might not work as well. And another thing we are sort of working on for a near future release is getting Teleport to produce audit logs about every single Kubernetes request and not just the exec style requests. So that means that you would really have very little need to look at the Kubernetes audit log and all of the same information you can get from Teleport log, and that would always have SSO identities attached.
Fantastic. Thank you very much. So do we have any other questions? All right, no other questions, and it's already 10:46. So looks like we are about done. Thank you, Andrew, for showing us the light. Thank you for answering questions. Everyone else, thank you for asking very smart and interesting questions, and thank you for attending. And if you'd like to learn more about modern secure access, if you want to learn more about Teleport, look, it's an open source thing. Go download it, play with it, dive into the code. I used to be a contributor myself. That code is very easy to understand. Enjoy this little tool. And also check out our blog at gravitational.com/blog. Obviously, follow us on Twitter. And on behalf of Gravitational, enjoy the rest of the day. Be happy sheltering in place and stay safe.